We're focused on what we can do rather than the consequences of what we are doing. And that's my first of three issues that I'm raising talking about IoT. Now, that naivete goes down over time, of course. Look at apps and smartphones. We went through the same thing. What I could do, social media, the same thing. And we're just repeating ourselves, but here, it has more dire consequences. Now, I will admit, before I started this project, this is what I thought of IoT. Consumer goods, refrigerators, toasters, doing whatever. It wasn't until I saw this diagram that I changed my opinion, and I realized the danger. Now, this thing, aside from looking very Star Trek-like Romulan warbird thing, if you look at it carefully, anything is potentially connected to everything else by the internet. And so it doesn't matter where I get in. If you have smart devices at your home that are controlled by an application, and that app is not sufficiently secure, somebody can hack into your house, not to necessarily get what you might have there, but to get somewhere else, to get access to the internet. And that's the real danger that we're talking about with IoT. Now let me, again, take this aspect and put a real-life example in front of you. Russian hydroelectric dam, the before and after photos. Where it says power units in the before photos, that's where the term. His network, as it frequently is, was under attack. But this time it was a DDoS attack of up to 600 gigabits per second. It got so bad that his provider, who was providing a free service, had to actually shut him off after a couple of days because it was taking down their network. And in the aftermath of this, the analysis, it was discovered that it was millions of IoT devices that had been infected. So all of your toasters, refrigerators, connected doorbells, heating systems, whatever it is, they'd all been infected with malware and turned into a massive botnet. So an unintended consequence. So again, we're looking at all of the possible consequences that we have here. So where, in the case that I've laid out, where does the answer lie? Well, in some cases, in some industries, it will be in the devices themselves. Because in certain instances where we're not as price sensitive, yes, they will take a greater amount of time designing them. There will be processing in memory, so you can put some client software in there. But in most cases, however, the answer has to be in the network. Now, at this point, I have to diverge a little bit, because today you have several options how you want to hook these IoT devices up. There are wide area networks specifically designed for IoT. There are cloud services. There's platforms that can be deployed. But what I'm going to focus on now are those devices which directly attach to an enterprise's network, whether they be cameras, sensors, or any other sort of device. But that's where I'm talking about. And that brings me to my third point, is the network itself. Because IoT is a new thing, but the problems that this network is facing or dealing with are not new. These are issues we're dealing with and have been dealing with for a number of years. And I can sum them up in three simple words: borderless, performance, and complexity. I'll explain each one of them, particularly about borderless, because that's the one that tends to get most people confused. Now, I've been in the networking business for a number of years, and I go back to old technologies. And in the old days, if you had a network, if you were lucky enough to have a network, it was yours. You had a physical site connected to another physical site with a piece of wire in the ground connecting it to it. But beginning with a technology called X25, followed on by frame relay, MPLS, the internet itself, cloud, all of these technologies came into the scene and were adopted, were taken in by the enterprise because they offered value. The consequence of those decisions was that My focus on security, which was typically outward looking and on the perimeter, was now being deteriorated. And every time I opened up my network by using yet another technology, the internet, wireless, whatever it may be, that perimeter, my security philosophy was deteriorating, or it disappeared completely. And it allowed more and more entry points for a hacker to get in. And if they can get in undetected, they sure as hell can get the data out undetected. The best example I have of this is what I consider to be the mother of all data breaches, the Target retail group in the US about 4 years ago. For me, this was the point when data breaches transitioned from being a geeky industry thing to touching the common person on the street, because now it was something tangible that happened to them. Target was a series of almost a comedy of errors. You had a hacker who was not particularly good, sending out a phishing email that a technician at an air conditioning company clicked on, gave up his login credentials. That air conditioning company was using a free sample version of a malware product as their state-of-the-art cyber defense. Once the hacker got into the air conditioning company, he realized there was an open connection into this other company called Target. And once he got into the Target network, he realized it was wide open. He could go anywhere he wanted. There was no segmentation, no isolation of sensitive data. He put malware into the network. 2 different security systems within the Target network detected the malware. The Target either didn't understand the alarms, didn't appreciate the severity, or just didn't see them. The one thing he did, however, that was brilliant. Once he got to the tens of millions of credit card details that he ultimately found, grouped them together, made files out of them, and scheduled file transfers out of the Target network to offshore servers during the business day. It was just common, I should say, it was just ordinary business traffic. Who was going to tell the difference? And that's the key of the issue here. If they can get in, they can get out. Now again, because of my background and being so old, I remember local area networks coming in, working at 4 megabits, 4 megabits with IBM, going to 10, and then the big battle, 10 going to 100. You don't even think about that anymore. 1, 10, 40, 100 gigabits, and what's beyond that? The problem, as the network itself has evolved and moved on in terms of speed, most security solutions can't keep up. So our customers, or people I'm talking to, have to make a decision. How much security can I afford before I slow down my network? And particularly in certain businesses, retail for example, if I start to slow down my applications, my point of sale, I'm affecting my business. So I scale back, I make a compromise, and a compromise nobody should be forced to make. And finally, complexity. And vendors need to raise their hand on this, because we're guilty of making this a big issue. Because we've been telling the marketplace, you have a problem, get the best product you can find for that problem. And when you have another problem, get another best product. Put them in your network, they'll work. And eventually what you have is a collection of very good products working exactly the way they're intended, but they were never intended to work together. And what happens is gaps develop between those individual products. That complexity, who's going to make it work? You are. Can you guarantee what you're trying to do is not going to have errors in it? And even if I focus on just one category of product, firewalls, common practice to mix and match different vendors. You can argue the pros and cons of that approach, but I understand you have different purchase cycles, different appreciation cycles, you have all of that. But even in that small scenario that I have one vendor at the branch, a different vendor in the data center, I can make them talk. That's not the problem. The issue is, can I create end-to-end security policies that do not have errors? And each one of those vendors should have a source of threat intelligence keeping their systems up to date. And let's say they do, that's great, but now you're managing multiple sources of threat intelligence. How do you synchronize the quality between them? How do you ensure that vendor A is as efficient as vendor C, and so on. And it's all of these things, this complexity, that reduces the security capabilities of the network. So if I look at those three problems again, the objectives from a security perspective are quite simple. Dealing with the borderless, the performance, the complexity, we want our security to be broad, powerful, and automated. Now, broad is fairly easy to understand in the context of borderless. What I want is the right collection of security technologies in my network to deal with all of my different attack vectors. But I want those products to work together, so in my day-to-day management, I have full visibility over the entire network without having to hop from one screen to the next or get somebody else to handle part of it. And at the same time, even though it may be broad, no vendor has every technology you will ever need at any given point in time. So how well can I, or how easily, can I integrate other technologies into my security infrastructure? Now, broad is easy, it's wide. It's talking about multiple things working together. But powerful, we want to add scale to it. Yes, it has to be able to handle the amount of data. But what we want to do is have the right product with the right level of protection at the right price for anywhere in the network. I don't want to have to sacrifice because I've made a choice with one particular vendor and their product for the branch office is just too expensive, so I'm forced to move on to somewhere else. And then finally, automate it. If you're going through the bother of putting a security philosophy into the network, you want it to work for you. You want to take advantage of the intelligence that should be in that security infrastructure and tell you where problems are. Be predictive. Hey, there's a problem with the endpoint. Antivirus isn't turned on. Or this configuration, there's a problem with it. You want the network to be part of your capability of managing on a day-to-day basis. You also want the ability, yeah, it's one thing to deal with threats that are 10 years old that we still see. What about the threat that was developed yesterday and spreading around the internet? Or what about, let's use WannaCry as an example. That's an attack that never should have happened. So are your systems being kept up to date? But do they have the ability to detect when something new is going on? They can't block it if they've never seen it. But you should have the ability to detect suspicious activity, to detect malicious or suspicious attachments or URLs that come into the network. And it's these three things that have to work together. Now, everything I've just talked about has absolutely nothing to do with IoT. That's the foundation from which we're working from. Now, if I come in and add IoT on top of this, it's just one of the many things that can happen in the network that every time I add one of these devices, I'm changing my attack surface. And so do I want to go, or am I forced to go in and look at the network? Okay, I'm adding these devices, I need to configure this and do something over here. No, I want the network to do that for me. I want the network, first of all, to learn that device that's attaching to the network. And I don't care where it is or what kind of device it is. I want the network to learn it automatically. And from that knowledge, I want it to place that device into a category. I want it to segment it. And with that segmentation comes my protection. Now, what I mean by that, here's a very simple example. I'm going to create 3 categories that these IoT devices can go into. Things that I'm managing, things I'll tolerate, and things I don't want anywhere near the network itself. So when you're considering this, it's not just the sensors. Remember, IoT, the T means everything connected to the network. So laptops, servers, everything that's already in there. Those devices typically have clients on them that I can manage them by, or at least I know that these are resources or assets in the network that, yes, they're already there, I know where they are, and I will put them into this trusted category. And each one of these categories has access rights associated with it, where it can go and where it cannot go. So fine, let's start with that. Now, I come into the tolerate. You have guest Wi-Fi set up in your offices. Somebody comes in and gets onto the guest network. That's a thing. That thing should be identified, and if it's coming over what is identified as the guest network, fine. I'll tolerate it, but I'll restrict its access. I'll only give it internet access. And then finally, anything else that shows up in the network, I'm considering it rogue. All of a sudden, an IPTV shows up in the data center where there's never been one before and there's no reason to have one. The network should respond, tell me, and block it, put it into the rogue category, and shut it off from the rest of the network until I can investigate who brought in a television to work. So that's what we're talking about, having the network work for you when you're dealing with IoT. But again, dealing with those other problems that I talked about. Now, different vendors approach this in different ways. Fortinet's philosophy is something called the Fortinet Security Fabric. And this is our technology vision of multiple technologies integrated together to fulfill all of those things that I talked about. That concept of being broad, powerful, and automated. It's not a product. You can't buy it. But every product that you do take from Fortinet has the security fabric built into it. So to wrap this up, the biggest thing, and going back to what I said in the beginning about understanding the consequences of what you're doing, before jumping in and both feet IoT is the greatest thing in the world, a couple of things to take into account. What are all these devices? Can I physically handle all of those connections? What about the data that comes from each one of them? In its aggregate, it can be massive. But more importantly, it's IoT today. Next year, it'll be something else. Last year, it was something different. There's always something coming that's having an impact on the network. The thing that doesn't change, however, is the security philosophy supporting that. And that's what the Fortinet Security Fabric is all about. Having that philosophy, having that vision that deals with today and accommodates tomorrow. Hope I've given you something to think about. Please feel free to visit our booth. The local team is there to answer any questions. Thank you very much.
That's it?